Alright, so I'm going to be talking about marine ecosystems. So, going down on the slide, we have the marine environment is an aquatic ecosystem influenced by the presence of various salts, usually chlorides, and subsets of sodium and magnesium, as well as calcium. The composition of seawater is essentially fresh water with large numbers of dissolved materials, and primary we would have right there magnesium, sodiums, and the list is on the table. So we have a principle of constant proportions. The composition of the dissolved materials varies little throughout the world's ocean. The principle of constant proportion states that the relative amounts of the various ions in seawater are always the same. This is the proportions of dissolved salts are relatively constant, although the total amount of dissolved salts in seawater may vary geographically. So now we have salinity. Salinity is the term used to describe the amount of dissolved materials in seawater. Salinity originally referred to the dry weight of salts per kg of seawater. Later, salinity referred to the chloride content of seawater. Now, salinity refers to the conductivity. That is, the conductivity of a sample of seawater in comparison to the standard solution of potassium chloride, KCI, in which the mass fraction of KCI is 32.435 times 10 minus 3. The temperature is 15 degrees Celsius and the pressure is 1 atm. Continuing our explanation, salinity is expressed as the ratio of dissolved materials to the amount of water. This is G dissolved solids 1000 G H2O. Therefore, if salinity is 34.7%, then there are 34.7 grams of dissolved materials in 100 grams of seawater. This could be written as 33.47%, while others would actually write it as 96.53% of water. Okay, variability of salinity within the ocean. Although the proportions of dissolved salts are relatively constant, the concentration of salt changes with the addition or removal of water. Therefore, salinity varies caused by the local rate of evaporation, the local rate of precipitation, the volume of fresh water discharged in the ocean basin. For example, rivers and melting of polar ice. So now I have a diagram. In this diagram, we have region and salinity. So there's the Red Sea, which is 40%, Mediterranean Sea, which is 38%, of the Black Sea, which is 18%. We have the Guam, which is 34%, and then we have Baltic Sea, which is 8%. Notice that the salinity is below the global average in the subpolar in temperature or temperate regions between 40 degrees and 70 degrees latitude. Precipitation is generally greater than evaporation in this zone. In the tropics and temperate region between 10 degrees and 40 degrees latitude, the salinity is greater than average. Evaporation is greater than precipitation in this zone. Okay, going on, we have salinity varies not only geographically but vertically in the water column. The halide line is a water layer characterized by the large salinity changes over small changes in the depth. Now we have an example, which is in Guam. The halide is found at 100 meters depth, as you can see. Despite the global variability and salinity of the ocean, This is not increasing because the inputs of ions are balanced by outputs of ions actually. Inputs we have liver discharge adds ions, especially magnesium ions. They meet oceanic ridge and hydrothermal vents, submarine and terrestrial volcanoes add ions, especially HS and Ci. Outputs we have chemical precipitation, especially in crust and nodules. Ions incorporated in living organisms, especially carbonate and siliceous shells, removal by wind and wave action. Going on, we have dissolved gases in water. Dissolved oxygen. Organisms used to release energy during cellular respiration, although the atmosphere contains about 12% of oxygen, though in the sea varies from 0 to 9 milliliters ppm. Major sources of dissolved oxygen. I have the primary source of dissolved oxygen is photosynthesis by photoplankton. Because plants produce more oxygen than seawater can dissolve. We have excess of oxygen diffused into the atmosphere. About 50% of the atmospheric oxygen comes from the oceanic photosynthesis. The secondary source of dissolved oxygen is turbulence. For example, water movement, especially surface winds and waves. The concentration of dissolved oxygen varies with depth. Dissolved oxygen is abundant in surface waters because of photosynthesis and turbulence. Dissolved oxygen concentrations decline with depth down to the oxygen minimum layer. Okay, ongoing we have dissolved concentrations approach 0 ppm in the oxygen minimum layer because of oxygen consumption by bacterial respiration. Dissolved oxygen levels rise below the oxygen minimum layer because fewer animals are present, and organisms inhabiting colder water have lower metabolic rates and slower rates of oxygen consumption. Now we've moved on to temperature. Temperature is one of the most important physical factors in the ocean because it affects density, viscosity, salinity, and the concentration of dissolved gases, as well as influencing the metabolic and reproductive rates of organisms. Ongoing, we have temperature varies seasonally with solar radiation. The seasonal range of temperatures at any locality is affected by latitude, depth, and nearness to shore. Now we have a whole diagram taken in June 20th to 24, as you can see, and they're showing the temperature levels in different places, as you can see. So that's how this diagram is being laid out. Alright, so ongoing we have temperature decreases gradually with depth down to the thermocline where temperature increases rapidly with depth. Below the thermocline, temperature decreases gradually down its minimum in the deepest parts of the ocean. In the tropics, the thermocline is deeper. So now we have light. Almost all life on Earth ultimately depends upon the energy from the sun. Energy transmitted from the sun reaches the Earth as electromagnetic radiation. As you can see, there's a diagram over here showing the electromagnetic spectrum. Visible light striking the ocean surface is reflected and absorbed and transmitted. Energy in the visible wavelength is captured by marine plants possessing chlorophyll and Accessory pigments. Marine plants use the energy to combine H2O and CO2 to manufacture their own food in the process known as photosynthesis. Because they are capable of manufacturing the organic compounds necessary for their metabolism, they are called autotrophs. Vertical zonation of light in the ocean. We have photic zone, euphotic zone, compensation depth, dysphotic zone, and aphotic zone. And there's a little diagram showing that right now. And going towards that, we have absorption of light by water is selective. Longer wavelength, the red, you know, end of the spectrum, and of the light that are absorbed first, and the shorter wavelength, the violet end of the spectrum, penetrate the greater depth, and the order absorption is red, orange, yellow, green, blue, violet, and indigo. All the red wavelengths are absorbed by top 1 meter of the ocean, and that is it for the marine ecosystems.